Lesson 5.3 deals with triangles, and there's an experiment that they've done for us over here, which is kind of a cool experiment. If you take any triangle, you can just cut a triangle right out of a piece of paper, and let's say that we call this angle A, this angle B, and this angle C down here. If you can see very lightly, they have the triangle that was drawn for us. If they rip off, or you rip off angle A and rip off angle B, and line them up here, so there was angle A, there was angle B, you can see that together they form this straight angle. And we know from our previous work that a straight angle has 180 degrees. So it's showing you here, this is this torn triangle demonstrates an important geometry theorem that's called the triangle sum theorem. So this shows you essentially why the three angles in a triangle add up to 180 degrees. And you can actually do this with any size triangle. Big, small, doesn't matter what the angle started out to be. When you tear them off and line them up, you will always get a straight angle of 180 degrees. Okay, here we have some theorems to do. Or words, numbers, and algebra with the triangle sum theorem. And the first one, the angle measures of a triangle add to 180 degrees. So please go ahead and underline that to make it important. 180 degrees. Here it's showing it with numbers. If you take these three angle measurements and add them up, again you get 180 degrees. And with algebra, they don't tell us what the R, S, and T are, but I know regardless they have to add up to 180 degrees. All right, we do have some fill-ins here. And blank has three acute angles. And the answer is an acute triangle has three acute angles. And here's an example of an acute triangle. Remember, an acute angle is an angle that's greater than 0 but less than 90. So an acute triangle, all three of these would be acute. And blank has one right angle, or I'm sorry, a blank has one right angle, and that's a right triangle. Remember, a right triangle has the one right angle in the corner, and it can't have more than one right angle because the sum total has to equal 180. So if I have more than one right angle, I'm going to automatically have 90 plus 90. That takes the 180, and then I wouldn't have a third angle in the triangle. And finally, an blank has one obtuse angle, and that would be an obtuse triangle. And here's an example of an obtuse triangle. Remember, the obtuse angle here has to be more than 90 and less than 180. So here's the obtuse angle. And then these two angles right here, this one would be acute, and this one would be acute. Same thing on the right angle, or the right triangle. You'd have one right angle and two acute angles. Here's an example where they want us to actually find the missing angle measure. So this is a right triangle because it has the one right angle. So I know that the 42 degrees plus, whoops, my right angle, which is 90 degrees, plus the C degrees, has to add up to 180 degrees. So I'll just add 42 and 90. That gives me 132 plus C equals 180. And then to finish solving this, I'll subtract 132 from both sides. When I do that, I end up with 48 degrees. And you can check it. You can go back and add 48, 42, and 90 and see that it does actually equal 180. So now we have another way to classify our triangles. Here we have an blank has three congruent sides and three congruent angles. That's an equilateral triangle. Three congruent sides, three congruent angles. And here's a picture for you. Three congruent sides and three congruent angles. And blank has at least two congruent sides and two congruent angles, and that's an isosceles triangle. An isosceles triangle has at least, because technically an equilateral triangle does cover the basis for an isosceles triangle. But in isosceles, you have to have at least two sides congruent and two angles that are congruent. And these angles are actually called the base angles. So let me label these here for you. This is equilateral. And this was isosceles. That is not how you spell isosceles. There we go. And then a blank has no congruent sides, no congruent angles, and that would be a scalene triangle. So this one is scalene, and you don't mark it up at all because there's nothing that it has no sides, no angles in common. Nothing congruent. Okay, so here are a couple more. They want us to figure out the angle measure. So find x in an acute triangle. So remember, acute, all three angles are less than 90. But we'll just go around the angles and add them up. So 63 plus 42 plus our x, we know the total has to be 180. So I'll add these to get 105 plus x equals 180. We would subtract the 105. And so x equals 75. So the missing angle is 75 degrees. This one says find the angle measures in the isosceles triangle. So we know that we have the two angles that are the same. So I have 62 plus a t plus another t. So there's my three angles, and altogether they're 180 degrees. So I'll go 62 plus t is 2t. Remember, collect your like terms. And look at here, we haven't had one of these in a while. Remember, this is a two-step equation. So we will subtract the 62 from both sides, and we get 2t equals 118. 180 minus 62. Divide by the 2, and t equals 59. So each of these are 59 degrees. Oh my goodness. 59 degrees. And you could add them and just make sure that 59 plus 59 plus 62 add up to 180 degrees. Let's try another one. It says find the angle measures in the equilateral triangle. Well, equilateral, remember, all three angles are the same, so they're calling them m. So we have m plus m equals 180. Well, we could have just really started out with 3m equals 180. Divide by 3, and m equals 60. So all of these are 60 degrees. Now the scalene triangle, they've not really given me anything except a 3p, a 4p, and a 2p. So all I can do right now is write that down. 3p plus 4p plus 2p. I know that altogether they have to add up to 180. So now I'm just going to collect my like terms. I have 3 plus 4 is 7, plus 2 is 9p equals 180. Divide by the 9, and p equals 20. Now that's not giving me my angle measure. That just tells me that p is 20. So this angle is 4 times 20. So this one's 80 degrees. This angle is 3 times 20. So this angle is 60 degrees. And this is 2 times 20. So this angle is 40 degrees. And if we add them around, 60 plus 40 plus 80 is 180 degrees. So it does work out for us. Okay, next it says finding angles in a triangle that meets given conditions. So it says the second angle in a triangle is twice as large as the first. I'm going to call the first angle x. So it says the second angle is twice as large as the first. So if this is the first angle, my second angle is twice as large as the first. So I'm going to call that 2x. And the third angle is half as large as the second. So the third angle is half as large as the second, so half of 2x is just an x. And then it says, find the angle measures and draw a possible figure. Okay, I'm going to add these three up and set them equal to 180. So I get x plus 2x is 3x plus x is 4x equals 180. Divide by 4, and 180 divided by 4 gives me 45 degrees. Now, if you look at this, I know that angle 1 is 45 degrees and angle 3 is 45 degrees. 2 times 45, angle 2 is 90 degrees. So it says draw a possible picture. I know by looking at this information that I have two angles that are the same, so it has to be isosceles, plus I have a right angle. So this has to be a right isosceles triangle. So I could draw it like this and go 45 degrees, 45 degrees, and that's a possibility for what it could look like. Okay, let's do another one of these. It says the second angle is a triangle. So I've got first angle, second angle, third angle. The second angle in a triangle is 6 times as large as the first. Well, again, I'm going to call the first one x. The second one is 6 times as large, so that's 6x. And the third is half as large as the second. Half of 6x is 3x. So I'll do the same thing, and I'll add these up. I've set them to 180. So x plus 6x is 7x plus 3x is 10x. Come on. Divide by the 10, and x equals 18 degrees. So I know that angle 1 is 18 degrees. Angle 2 is 6 times 18. And that's 108 degrees. Angle 3 is 3 times x, so 3 times 18 is 54 degrees. Oops, 54 degrees. Well, I can tell that this is an obtuse triangle right here because I have an obtuse angle, and it's scalene. Scalene, none of the angles, none of the sides are the same. So if none of the angles are the same, then none of the sides can be the same. So I will draw it so it looks something like this. And I would put in here, oops, I guess let me get to the right tool. There we go. I could say this is my 108 degrees, it's my largest one. And it looks to me like this is my smallest one, so there's 18 degrees and there's my 54 degrees. So there's a possibility for it. Okay. Oh, we've got another fill-in. The blank, the triangle inequality theorem. Important theorem. It says that the sum, which remember means addition, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So what that means is any two sides that I add up, they have to be greater than the remaining side. So 4 plus 7 is 11, which is bigger than 5. 4 plus 5 is 9, which is bigger than 7. 5 plus 7 is 12, which is bigger than 4, so it works. Here, 4 plus 7 is 11, it's bigger than 2, that works. 4 plus 2 is 6, not bigger than 7, so it could not possibly form a triangle. So let's check these. We have 9, 4, and 11. So 9 plus 4, let's see if that's greater than 11. 9 plus 4 is 13, is greater than 11, so that works. Let's see if 4 plus 11 is greater than 9. 4 plus 11 is 15, which is greater than 9, so that works. And now I have to try the 9 plus 11 and see if that's greater than 4. And it is greater than 4. So yes, that could be the sides of a triangle. Let's try this one. 6 plus 3, is that greater than 10? 6 plus 3 is 9. Uh-oh, it's not greater than 10, which is kind of nice we found it right away. We just put a little slash through it. So this answer is no. We don't even have to go further because the first thing that we checked out did not work. Hey, guess what? We're done with notes. If you want to try the assignment, or not try it, but get it started ahead of time, it's page 205 to 210, problems 10 to 27, 30 to 33, 35, and 37.